Hello, I'm Dr. Geertrouw, and today I will be reviewing a very particular but funny game, Quantum Conundrum. I actually remember wanting to use this game for my master thesis when it came out in 2012, but I really didn't have the money at the time, so I couldn't use it. But well, let's just go through the game. Today I will be reviewing Quantum Conundrum and its links with physico-mechanical reasoning and problem solving. I will also talk a bit about spatial navigation, as the game shows us a type of visuospatial reasoning we have not seen before. Quantum Conundrum is a single-player, first-person platformer puzzle game, developed by Airtight Games, published by Square Enix, and designed by Kim Swift. It was released for Windows in 2012, and that's the version I'm playing for the review. I will start reviewing the story of the game and doing a brief analysis of the narrative. As usual, I will try to keep this as general as possible without telling anything about the ending of the game. However, this section might contain spoilers. If you really want to avoid spoilers, just jump to this place in the video. Also, from now on, I will make highlights of the different sections of the video in case you are interested only on a specific part of the review. So yeah, let's go! The game starts where your mom, who is the sister of an egocentric eccentric scientist, takes you to his house for you to spend your vacation there. She thinks it will be good for him to get some company and has sent you there before. You are a 12-year-old boy, and when you arrive at the house something doesn't feel quite right, and soon a very weird accident happens. Your uncle is nowhere to be seen, but he can communicate with you and somehow he can see you as well. He tells you that he is trapped in a pocket dimension, but he has no memory of why he is there. Due to the accident, the house is under lockdown and all the electricity has been turned down except for the emergency power. So your uncle, Professor Fitzquadrangle, thinks there is only one way to find out what happened and also to lift the lockdown so you can leave his home. And that is to turn on the 4 main reactors that power the house. As he is trapped in the pocket dimension, you will have to do it. He gives you access to his latest invention, a globe that allows him to manipulate the entrance to different dimensions. The objects in these dimensions are exactly as the ones in your dimension, but with different physical properties. So you start your trip around the huge mansion, finding different capsules to power the globe, allowing you to access the different dimensions. This is not simple, as you need to solve intricate puzzles, product of your uncle's experiments, so you can power the reactors and free your uncle. The narrative of the game is really the narrative of the anti-hero. You are just a normal 12-year-old child who was put in this weird mansion with your egocentric and eccentric uncle by your mom. You have no superpowers, and as it is told very quickly in the game, you are kind of short for your age. And suddenly, you are put in the position of having to save your uncle if you want to leave the house at any point. You are not the person to solve the problem. You don't have the tools for it. You don't even know what is happening. Yet, you are forced to do it just so you can escape this crazy house. Eventually, you are given a tool that helps you in your way through. This is not a superpower, but basically the key to go through this madman's house. So yeah, we can say that despite the circumstances, you will make it through, eventually. Regarding the cognitive skills fostered by Quantum Conundrum, I can tell there are 3 skills the game really taps on, and those are problem solving, physico-mechanical reasoning, and egocentric visuospatial navigation, which is a part of our visuospatial reasoning, but let's talk about that more in depth. Problem solving is a set of psychological skills that have been highly studied in psychology. It consists basically on being able to find a path or solution, taking you from an initial state of a system, a starting point, to an end and desired state or goal, using a series of rules, which for a game we call mechanics. There are basically 2 types of problems, well-defined problems and ill-defined problems. Well-defined problems are those where the starting point, the goal, and the mechanics are well-defined, and it is up to the solver to find the correct path or solution to take the system from the initial state to the goal state. These problems often have one path, or several known paths, with one being more efficient than others. An example of this problem is Minesweeper. In Minesweeper, you have an initial state, a grid with divided tiles, a goal, to find the mines, and a series of rules, marking the mines and following the signals indicating if a mine is nearby. Normally, well-defined problems are not natural but created, as most of our everyday life problems lack one or more of the components a well-defined problem requires. Ill-defined problems are those where at least one of the components defining a well-defined problem is lacking. For example, we may know the starting point, but either the goal or the mechanics or both are unknown, so finding a solution is more difficult. These problems do not have one path, or a path that is more efficient than others. Normally, the solution involves finding an equilibrium between different goals instead of one defined goal. Examples of these problems are city building games, where you have to maintain a constant equilibrium between what different people desire. There is not one correct solution, and you might choose to listen or support a certain sector instead of another, or try to make everyone happy for some time until the conditions change. In order to solve problems, we use our executive functions, particularly planning and strategy making. For example, mentally trying a route or a series of actions and mentally simulating the outcome. But we can also use other strategies, like trial and error, which can be very useful when the rules have not been specifically stated. Trial and error is systematic and aims to gather information that is implicit in a problem, or the boundaries of the rules. There is also brute force strategy, which means that you try every single thing until something happens. This strategy is not necessarily systematic and does not aim to learn anything from the system, but just to achieve the goal. In Quantum Conundrum, we can see problem solving in each of the puzzles the game presents to us. We know the basic rules, we juggle a bit with them, then we find a way to use them to our advantage, and we open the path to the level and are presented with a new and more challenging puzzle. Sometimes we know the behavior of the objects of the room and can plan ahead our steps. Sometimes we need to play around with the rules to understand new affordances or uses we can give to them. And sometimes we are presented with new objects or rules that we need to learn how to use and adapt to. But all of this is part of the challenge. To solve these problems, you have a whole arsenal of mechanics. First, there is the main mechanic of the game, which is the dimensional shifting. Depending on the dimension, you can make objects be lighter, heavier, or slower than they are, or reverse the gravity of the room. Then, you have all the other mechanics, like running, jumping, grabbing and throwing objects, and standing on them. Here is where the game starts becoming interesting, when you have to combine all of these mechanics in order to solve a problem. Take for example here, you need something heavy to press these buttons, but you cannot lift heavy stuff. So you need to switch dimensions so the object becomes lighter. Then you can move it to the button and turn to the regular dimension so the button is pressed by the heavy object. Another example are these spring buttons that feed on kinetic energy. To make this work, you need to switch dimensions at the correct time to make objects light and heavy until you gather enough kinetic energy to reach your goal. Another skill this game taps on is physico-mechanical reasoning. Physico-mechanical reasoning is the reasoning about the physical and mechanical properties of the world, and allows us to calculate things like if we can cross the street before a car can hit us, or how hard do we have to kick a ball for it to get to the place we want it to be. Although we use physico-mechanical reasoning all the time in our everyday life, this reasoning type in games consists of understanding and adapting to the rules of the game universe and using them to our advantage. For instance, how quick can a character move underwater, or how fast do they fall when jumping? Quantum Conundrum plays with these rules all the time, as the different buttons of our globe allow us to manipulate the physical properties of the universe, although for the game we are indeed switching dimensions. This forces us not only to learn new and different physical properties of the world, but to play with them in a synergetic way so we can reach our goals. Although while playing the game you are not learning anything from the physical properties of the real world, you are learning to adapt to different circumstances and environments, and to play with the rules of this universe for solving problems. Is it too heavy? I will make it lighter for you. You cannot reach that place? No problem. Throw a table and stand on it so it flies with you on it. Another skill the game fosters is egocentric visuospatial navigation. Visuospatial navigation is a part of our visuospatial reasoning, and it allows us to navigate the world using cues from the environment or transposing representations from 2D to 3D like when we read maps. There are two types of visuospatial navigation. Allocentric navigation, which is when we navigate using the reference of a third person or actor of the environment. For example, when we play a character from a third-person perspective and we can look at the surroundings, we are looking at the game as if we were reading a map. Having access to different actors, perspectives, and environmental cues allows us, for instance, to plan routes. Then we have egocentric navigation, which is when we navigate using our own perspective as reference. We do this in our everyday life, when we try to reach a place using only environmental cues, the memory of our surroundings, or verbal instructions from a friend. Quantum Conundrum and pretty much every first-person game foster egocentric visuospatial navigation, as you have to look at your surroundings, get familiar with its cues, and use your own perspective in order to realize where you are, where you want to go, and which routes are good to achieve this goal. Also, to realize when you have arrived at the place you want to be, so you don't continue navigating the map forever. Sometimes these two get combined, like when you read maps and then you have to transform the 2D representations of the cues into your 3D environmental cues to guide yourself. This is, however, not the case for Quantum Conundrum. Here you only have egocentric navigation. The game is very well designed, but I must particularly praise the level design. Designing puzzles is not an easy task, and the designers of this game just get it in such a masterful way. The learning curve is not too steep to make it frustrating, or too smooth to make it boring. The level design depicts a systematic progression on difficulty, introducing new mechanics, allowing you to try them in a safe way, then combining them with the old mechanics, and finally giving you control over the newly acquired mechanic for you to freely play with them and solve the puzzles. This progression is achieved thanks to a set of level divisions. First of all, the game is divided into 4 big sections, each of them introducing a new dimension. This allows you to juggle with their mechanics and learn them while combining them with the regular mechanics of running and jumping. The game is also divided into single puzzles. Each puzzle belongs to a room, and the goal is always to leave the room, either by opening the door, reaching the end of the level, or both. This allows you to focus on one puzzle at a time, so you can restart the level if you got lost, or to stop the puzzle to retake it later if you're stuck and feeling frustrated. Regarding the character design, it is really story-based. You learn and understand the personalities of the main character, Professor Fitzquadrangle, by means of the dialogues. You only see him in pictures, pretty much all the time to be honest, and you hear him all the time. He has a very witty humor, full of puns and linguistic plays. Actually, I like his humor very much.
You probably never saw this invention. It was my hole digger. We called it Every Day I'm Shoveling. And by we, I mean Ike. It was a little too efficient. This was the first and last time I saw it.
He is also pretty conceited and believes himself to be the smartest person on Earth, which in this universe is kind of true, as he is the only person in the world who has been able to single-handedly access rifts to other dimensions. We also see some of his other failed inventions during the game, like a jetpack that sets your booty on fire, or a freezing gun that froze itself. Then there is the silent 12-year-old protagonist, you. There is really not much to say here apart from the fact that you are a 12-year-old boy trying to solve intricate and deadly puzzles in order to save your careless uncle. There is only one picture of you in the mansion, and it is hidden away. Finally, there is Ike, interdimensional kinetic entity. He has the power to travel within dimensions and space-time without being affected by the physical constraints of the dimensions. He is kind of a helper, holding things for you from time to time. However, he really doesn't help you. It doesn't say anything, and far from bringing comic or cute relief to the game, it looks pretty scary. The graphic design is pretty clean, although it changes to fit every dimension, so the fluff dimension looks plushy, while the heavy dimension looks metal. The game itself has lots of recycled assets, meaning that most of the things we see, from objects we interact with to level decoration, obstacles, and design, are repeated again and again in each puzzle. This is okay, as it is a puzzle game, and we want to have familiar obstacles and items so we don't have to learn new interactions all the time. However, at a certain point it starts feeling kind of repetitive, giving you déjà vu vibes. However, there are some details I particularly like, and these are the paintings. Most of the humor of the game is linked to the paintings. They change what they portrayed according to the dimension you are in. For example, they get cute in the fluffy dimension and metal in the heavy dimension. Also, sometimes Professor Quadrangle will tell you of an adventure he and Ike had when traveling through time, or what happened with one of his experiments.
I just had to pass Widget II through Dolly again. I just couldn't resist. Definitely learned my lesson with this one. Technically, his name is Widget III, though he often responds to derp. I often find him walking around in circles while staring at his feet. Very friendly, but possesses the intelligence of a sack of rocks.
The music of the game is really great. Composed by Chris Ballou, the music of Quantum Conundrum is mostly electronic environmental music that accompanies you through the game. It blends very well with the environment and prevents you from feeling lonely in the game. However, it is not outstanding either. The fact that it is not outstanding is also good, as it is not interrupting your train of thought or getting annoying while you try to solve a puzzle, so it is indeed very well designed. However, the outro song is an amazing and very funny song. Check it yourself.
Then I flip a switch and fluffy is everything. Plush and sweet and soft and pink. I flip a switch and heavy is everywhere. Crash to the ground from out of the air. I flip a switch and time goes down, down, down. Stretching thin and stretching out. I flip a switch, lose the gravity. Light as a feather and floating free.
As I have said before, games are cradles for metaphors. We can interpret a story based on our beliefs or our experiences, or follow an implicit or explicit meaning the writers want to give to us. Sometimes this is pretty straightforward, as we saw with Dust, but sometimes we can get more meanings from what we read. The one metaphor I gathered from the game is related to the dangers of science, how scientific efforts can be misused, how unsupervised scientific research can be particularly dangerous, and how curiosity can turn into trouble. Science can be great. It can lead to great advances. It helps us to understand the world, to harness energy, to make better decisions, to make better use of our resources, and to live better. However, in the wrong hands, science can be dangerous. If you think about it, it was the effort for understanding better ways to create energy so we could live better which paved the road to the atomic bomb. The same might happen with curiosity and unsupervised science. And that's why science is done within groups of knowledgeable people that push for their correct direction, testing and use. We should not forget that some people have done great damage to the world and to others trying to understand a specific natural or social phenomenon. Curiosity is great for exploration and advance, but careless curiosity can be dangerous. The game is very well designed and really exceptional in what relates to fostering problem-solving skills. However, there is a problem I see with the game, particularly when using it in formal settings. And that is that the game, despite of the name, doesn't depict anything related to quantum physics. The problem I see here is that due to the name, particularly teachers will be tempted to give this game to their students, either hoping for them to learn something related to quantum physics in a simulation or metaphoric way, or using the game as a platform to introduce quantum theory to the classroom. However, far from depicting quantum physics, it gets some of its facts wrong. The game does not depict any of the key concepts of quantum physics, such as duality wave-particle, tunneling, or quantum superposition. Instead, it shows quantum physics as being about dimensional traveling, which is not. It also depicts wrongly some of the relativistic theory assumptions, like lasers traveling slower than light. Although these make good mechanics for puzzle solving, it is not really a good starter for a discussion about real-world physics. If you want to get into games to introduce quantum or relativistic physics to your children or students, I will put some links in the video description. I will also link you to some scientific communication channels related to quantum physics, both in English, Spanish, French, and Danish. So, what can you learn from the game if you're a regular gamer, or a parent that wants to use it in their household, or a teacher that wants to use it in their classroom? What can you learn from them? How can you implement it in formal and informal settings? Well, if you're a regular gamer that wants to foster problem-solving skills, you just have to follow the natural, organic way of the game, and by the end of the game, I promise you, you will have solved some crazy puzzles. If you're a parent or a teacher wanting to foster problem-solving skills, you might want to follow the way your students and children are solving puzzles. For example, are they getting stuck? And if they are getting stuck, it's because they don't understand the mechanics of the game. Are they trying alternative solutions, or maybe they are just trying the same solution again and again, expecting a different outcome? You might also want to ask questions that allows them to reflect on the way they are solving a problem, so they can think more about it. And maybe you might want to do alternative activities, such as making the children draw their own levels, either using the same mechanics that they have seen in the game, or inventing their own dimensions with different physical properties. For physico-mechanical reasoning, you are actually learning it and relearning it all the time, because the game just features all these dimensions with different physical properties that you have to learn and understand on how to use. If you are using the game in the household or in the classroom, you might actually want to ask the children about how our world would behave, or how will it look if we have these properties going around, or maybe why we cannot do some of the things you can do in the game, like throwing a table and then stepping on it and then fly to the other side of the room driving the table. Visuospatial navigation is a bit more difficult to assess. If you are a gamer, you probably already know how good you are at navigating games like this. If you want to use the game in your household or in the classroom, you might want to check how children are guiding themselves through the levels, or if they are getting lost, and asking some questions about the ways they are identifying environmental cues and guiding themselves through the level. Additionally, if you want to make another activity, you can ask them to draw the map of a specific level and see if they are identifying the environmental cues correctly, like their location or their shape. Take the game and give it a try. From the plus side, the game is non-violent, so the uses in classrooms are really broad. Also, the game organically fosters lots of skills, and if you get the jokes of Professor Quadrangle, you will have a lot of fun. Just remember that the game is not really about quantum physics. And that's all for today, and see you in the next video. If you find my videos interesting, please leave a like or a comment, and consider subscribing to my channel for more content.